Welcome, everyone, to the latest edition of the FedScoop Government Technology Webinar Series, sponsored today by BMC. I'm your host, Wyatt Cash, Vice President of Content Strategy for FedScoop, and today we take a look at the topic of big data and specifically setting the right foundation for big data analytics, and taking a look at what agencies need to know about the rapid evolution of big data analysis and properly preparing for the inevitable constraints. It's going to be a great show, and glad you could be with us. Joining us today are three veteran government IT leaders who've tackled some of these issues and directly and have kindly agreed to share some of their lessons that they've learned. So I'm pleased to welcome first Dr. Michael Valavula. Michael is the Chief Technology Officer at the National Agricultural Statistics Service at USDA. Welcome to the program, Michael.
Thank you, Wyatt. Glad to be here.
Also joining us today, we have Joe Goldberg. Joe is the Lead Solutions Manager for BMC. Joe, welcome to the program.
Thanks very much. I'd like to second my pleasure at being here.
Terrific. And finally, and not least, though, we have Rajiv Mather. Rajiv is the Director for Office of Online Services at the IRS. Rajiv, really glad you could join the program as well.
Thanks, Wyatt. Good to be here.
So I also, of course, want to welcome our audience, including those joining us live today, as well as those tuning in into the archived or on-demand edition of this program. And, of course, I'd like to thank BMC for sponsoring our program and making it possible today. Before we begin, I'd like to help our audience just get familiar briefly with our console and how they can participate. On your viewing console are multiple application widgets and that you can open and adjust in size to enhance your participation. We encourage everyone to submit questions to our presenters during the webcast using the Q&A on your screen. We will try to answer as many of those during the live webcast as we can, either during the presentation or towards the end of the program. You can also download a copy of today's entire slide deck using the resource list widget. If you don't see it on your screen, click the folder icon at the bottom of your console. And you can also expand the slide presentation window on your screen by clicking on the maximize icon on the top right of the slide area or dragging the bottom right corner of the slide area. And if you have any technical difficulties, please click on the Help widget. It has the question mark icon and covers common technical issues. And then finally, I just wanted to let you know that this program will be available on demand starting tomorrow, and will be available for up to 90 days. And that can be accessed using the same audience link that was sent to you earlier via email. So if you have colleagues who might benefit from today's presentations, please share the link with them. So let's get started. So Michael, you've been working on ways to improve how your organization deals with big data and big data analytics. Tell us a little bit about your experience at the NASS and a little bit of maybe some of the takeaways of what you've learned.
Sure, I'll be glad to. Thank you, Wyatt. Everybody, good afternoon. Thank you for joining us this afternoon. Hopefully, you will take something that will be useful from this conversation and discussion that we are going to be having. Without much ado, let's get started. And, if you look at the recent interest in big data analytics, it goes hand in hand with information of in Internet of Things. And we are going to see an avalanche of data that is being collected and utilized. It is going to be highly impossible for human beings to manage, manipulate, and analyze the data. So we need some way of analyzing the data. Before we get into the big data analytics, let's look at why we are here, how we got here. If you look at the economy, earlier economies, that we started off as an agrarian society, then we moved into the industrial economy, then into service-oriented economy. Now we are into this digital economy. So actually the data that we collect has value. we need to somehow release that value so that we benefit by that big data that we are collecting. To make it happen, we need analytics. Let's talk a little bit about why that is needed before we get in there. The reason why we need big data analytics is to increase the operational efficiency in whatever that we do, whether we are nonprofit or profit-minded organization, and we are also trying to reduce cost of operations. For example, the industrial companies like GE, Boeing, Northrop Grumman, Lockheed Martin, they manufacture very expensive machines like planes and tanks and things like that. They have operational technology that is running their machines every day. They are disconnected from the information technology that is managing the operational technology. What these companies are now doing, trying to merge that and increase the value and decrease the operational cost. Recently, I think about 5 months ago, McKinsey Global Research published this paper that said by 2025, the big data analytics and the Internet of Things would provide 3.9 to 11.1 trillion US dollars per year worth of value. That is a lot of money. And the amount of information that is going to be transmitted by Internet of Things by 2022, it is going to be about 44 zettabytes. Now it is about 3 to 4 zettabytes, but imagine that is going to be increasing in about 6 years to 44 zettabytes. That's a lot of big data that we are collecting just from Internet of Things. And every day there are more than 1 million devices that are connecting to the Internet today. Let's look at who the beneficiaries are of this big data and the analytics that is going to go with it. I apologize for the busy slide, but the idea is the beneficiaries are going to be mostly number 1, factories, number 2, cities, and logistics departments, and pretty much everybody is going to benefit from this big data analysis. So, pardon me, my slides disappeared from here, from the screen. So I need to get there. All right, sorry about that. So let's define what big data is. If you go back about 5 years, when cloud was in vogue, everybody was trying to define what a cloud is. Now, big data is getting to a form where people are defining big data based on their context. When NIST came out with a definition about 4 years ago for cloud data, pretty much everybody agreed that it's a reasonable definition. Now, I'm going to go with NIST with their definition to, define big data. Big data has the following characteristics. It refers to the inability of the traditional data architectures to efficiently handle the new data sets. So it is all relative. You may be a small agency, you have this legacy architecture, and you are getting this big data sets. If your existing architecture is not able to analyze that efficiently, you have a big data problem. It is all relative. So what are the characteristics does this big data have? It has got volume because the size is high. It has got different repositories, variety, domains from different domains, and different types of data. Then the velocity is the rate of flow because the data is coming per minute, per second, per hour, per day, per month, in whatever way that you collect the data, and the velocity is increasing. And the variability of the data is changing. All this constitute to big data. So what does the big data analysis require? It requires an architecture for efficient storage, manipulation, and analysis of this big data. So let's look at the big data analytics process. Data without metadata or context is useless. Just the number doesn't tell us anything unless it comes with some semantics or some context. So it is always better, or it is always required to collect metadata along with data. Then using the metadata and data, we create certain amount of logics or certain logics, algorithms to make sense out of the data. Then using algorithms, we create models to recognize patterns and relationship between these big data sets. Obviously, it is going to help us make decisions. Obviously, those decisions are going to be very objective instead of going to be subjective. The goal of big data analytic process to aid humans for making objective and better decisions for desired outcomes. How do we do it? It may be humans doing it, or it could be machine-to-machine communication. It could be machine learning. It is deep thinking machines. It could be just plain old automation. So let's look at the graphic, how it goes for a big data analysis model. Then we are going to have data, algorithms, and business intelligence going through an analysis or a model funnel, then giving us a pattern recognition or actionable intelligence that we can use to make our business decisions. What is important is the actionable intelligence based on the data that is relevant. Sometimes that can create problems. Using wrong models, wrong data, wrong business intelligence will give you a wrong answer. The process is right, but the product is wrong. Okay, let's look at the different data analytics types. In olden days, when we collected data, we sort of made sense out of it. We created matrices, Excel spreadsheet, whatever, we created a report. And usually it is more of a descriptive thing because we said, okay, this is what the data is telling us, and that is very descriptive. Then we got to a point where we started putting sensors on these machines and things and trying to find out what the anomaly is, and we made it sort of a diagnostic. Say, for example, in a generator that GE makes, in a big generator, they put about 30,000 sensors, but they could only analyze 1% of the information that is coming out. They are using it purely for diagnostic purposes because, they say, hey, before something goes wrong, we need to be able to diagnose it, or if something goes wrong, we need to find out why it went wrong. Then they went one step ahead. Okay, if we can diagnose this thing with big data, let us see how we can fix it before it becomes a problem. So they applied prescriptive models to get ahead of the problem so that if some engine overheats, okay, pour more oil into it, maybe the oil went dry. Maybe there is a leak. So that became more of a prescriptive. Now, more and more interest is in predictive analytics. That is, how can we predict the future based on our past or present? So there is a lot of interest in the predictive analytics right now, and the retailers, the law enforcement officers, and the credit card companies, they're all trying, insurance companies, they're trying to predict who is the right person or the people that they want to deal with and who are the bad guys, who is cheating, who is not cheating. These things can be predicted somehow based on the data that they are collecting from different sources. So that is where this is going to be becoming more and more useful in predictive analysis. Or I am going to go one step further. This predictive is going to become more of a pervasive analysis. So that is going to be another type of data analytics, which is going to be pervasive, that it is being constantly being analyzed. So looking at the person or a group of people who function as data scientists, we have heard this term data scientist over and over again, but in my opinion, data scientist is a unicorn because it is very hard to find a person who has these type of characteristics. According to NIST, a data scientist is a practitioner who has sufficient knowledge of the business, domain expertise, analytical skills, software and system engineering to manage end-to-end data process. That is going to be impossible task for any one person to do. Usually, this data scientist job is being done by a group of people. So because of the unavailability of the data scientists or not finding enough data scientists, I think the organization are moving somebody to a person called data strategist. Data strategist is a person who is tech-savvy business person, who has a good understanding of the business, can ask the right questions, and knows where to get the right data and how to transform the data and apply analytics that he or she has in their organization or hire someone to make sense out of the data. And that is the person who's going to be in greater demand because data scientist is like very hard to find. So that is where the trend is now towards data strategists, more of not on a data scientist at this point. Let's look at the best practices to set up a big data analytics program. And I do not know how many of you have heard of a person called David Linthicum. He has been a thought leader for a long time. Started off with data analytics and data integration, and then he went on to enterprise application integration. Then he wanted to do service-oriented architecture, then cloud computing. Now he is the big proponent of big data analytics. So I follow him closely, and I adapted some of his best practices to help us in the government agency arena. And what he says is that, these are the best practices one organization has to look at when they are setting up a big data analytics practice. That is, they need to define use cases first that they know of and the analytical models that they need. Then number two is, he says to have defined high-level core business requirements to create a business case. Then to focus on both strategic and tactical value of that particular big data strategy. Then one needs to define the agency data sources. Where is the data going to come from, and what is the data going to do, how the data integration is going to take place, how are we going to move from data point A to data point B. That is very important. The other best practice is to create a proof of concept just to learn first the technology and to better understand the complexities of bringing big data technology to the enterprise, because you don't want to boil the ocean. You want to just see whether you are capable or you have the resources, you have the technology, and you have the right data and the right models and right algorithms to create the right answers that you are looking for. By the way, only 12% of the big data projects succeed. Lots of them fail because they don't create a proof of concept or they don't quite understand. They just jump in head first and find out that that is not going to be useful for them because they don't have the right use case, they don't have the right resources, and they don't even have the right data, and they don't even know how to ask the right questions. So these are all kinds of problems that agencies are facing. In agency, when I say agency, it includes the for-profit corporations also. Then another set of best practices are the security and privacy. These are very, very important because, when we are collecting data, when we are storing data, manipulating data, we need to be, very careful about how we handle this data. Sometimes we, handle PII information, sometimes sensitive information, so we need to be very careful how we handle this data. Then another best practice to evaluate business intelligence tools and also data visualization tools to look into the data. Because if you don't have good business intelligence tools and good visualization tools, you won't be able to express the data in a way the users can understand. And also this process has to be transparent. So users need to know how that particular decision was derived, what are the algorithms were used, what data sources were used, so that they can trust the data or they can trust the actionable intelligence that the analyst provided. So that is very important. Then the next best practice is to have some sort of a metrics of success. How do we know that this big data analysis program really worked? So we need to have somewhat what is working, what is not working, How do we define success? Maybe after a year or so when we try to figure this out. Then also, another best practice is to have a roadmap of this technology. Okay, how are we going to go from A to B? What type of roadmap we are going to, technology roadmap we want to create? What type of architecture we need to move forward? And also keep an eye on the trends in technology that we are trying to implement or trying to modify. So this is very important because you don't want to go with a small company, then, it folds, then you are left out in the dark, not having been able to find out, what happened to the company. Then previously I talked about data governance as my sixth bullet point. But the thing is, I'm going to reiterate why this data governance is very important, because if you look at the collection of the data, validation of the data, managing the data, monitoring and maintaining, it's all very important because it is not any different from the relational data that we collect and we keep, because it is very important to manage the data very well so that we don't collect the wrong information and we don't, make decisions out of the information. Just collecting every possible piece of information is not going to help us, because it's going to create problems for us because we have to store, we have to manipulate. It is going to be garbage in, garbage out. We need to find out what is the right source, how to collect the data. And also then we need to control access to the data. Who has the rights? Who can see what type of models can be used where, because we don't want to just, give a hammer to somebody and then that person is going to be looking for a nail wherever they want to hit. All they know is just hit on the nail because all they have is a hammer. So we need to make sure that we provide the right tool to the right person and give them the right model, and they can make the right decision and use that tool very effectively. To reiterate, governance, risk management, and compliance, they go hand in hand with confidentiality, integrity, and availability. These are all very applicable to the big data as it is applicable to the small data. With that, I pass on the baton to the next speaker. Thank you for listening.
Well, thank you very much, Michael. Really appreciate that. And I want to invite our audience once again to submit your questions using the Q&A chat tool on your console. But I think I'd like to shift quickly now to Joe Goldberg at BMC. Joe, you have kind of a different perspective working with multiple clients and agencies. Tell us a little bit about your experience on this subject and what you're learning.
Great. Thanks very much. I think that Michael touched on a lot of points that we hear from many of the organizations that we work with and some of the challenges that they face. And I think probably you got the idea from Michael's talk that managing the big data wave that's coming could be fairly complex. And there's really quite a lot of technology options that are available. So, this slide is very much like an eye chart. It's really not meant for you to be able to read this in great detail, but it gives you just a sense, because there's a lot more than just this, of the choices that are available in the different categories of technology. And so, again, as Michael pointed out, you have to manage the process of collection of the data and how you store it and how you manage it. And all of these processes have quite a number of technology and tool and application choices. So, anyone who's been sort of following the big data space, they may have heard of technology called Hadoop. That's just one component of it, and there are just so many others. What many customers find, though, is that when they get into either a proof of concept or begin looking at starting up a big data initiative, usually that is being driven by some very high-level imperative, and it's really important for them to be able to execute quickly. And so speed becomes very important. And this is just one of the factors that complicates the entire process for them because, as Michael mentioned, there's quite a lot here that is both data sources, but traditional, or let's say classic data sources, are still part of the data environment that needs to be managed. I think Michael spoke at great length about the constraints in regards to resources that are either programming, staffing, getting the right kind of people, data scientists. It's really, really hard to be able to find the right kind of people. And when you find them, you want to make sure that you enable them to really focus on the task at hand of being able to, execute the big data strategy that you have. And, another thing that you have to really kind of be aware of is that all of this that you see in front of you, or the various technology and application choices, that is a continuing and evolving process. So if you look at what is called, the big data or the Hadoop ecosystem, and all of the components that are available, on a basis, some new stuff is coming along. And so the challenge becomes, how do you deal with all of that complexity as you're looking to embark on sort of this big data journey? So one of the things that most companies begin with is to create something called a data lake. Now, for those of you who are not familiar with that terminology, the data lake is kind of the big data equivalent of an enterprise data warehouse. It's a place where you can bring all your data together, both your traditional as well as your new categories of data, and begin to manage it. And so most customers find that they immediately see that there's processes associated with building and managing a data lake, such as movement of the data, collecting the new sources of data, as well as adding to it the sort of traditional relational databases and data that they've had in the organization for a long time. Now, this process of orchestrating, managing data ingest and managing data flows, frequently that falls on the shoulders of the data scientists, the data strategists, and the big data teams. And the way they have to deal with this complexity of managing all of that data, the various sources, and all of the technologies, is that they have to either use a great variety of tools, or they have to do a lot of sort of custom integration. And, frequently it's a combination of both. And so, coupled with the complexity of finding the right people and having the right resources, you're really kind of looking at a situation where you need to find somebody who looks kind of like this, who is able to do lots and lots of different things. And the thing that, sort of really makes this whole process even more complex is the fact that much of this work is not really the creative work of data analysis, of being able to find new insights. It's kind of mechanics and, fixing or building the plumbing. And as Michael mentioned, people like data scientists or data strategists are very rare, very hard to find. So the last thing that you really want them to do is to have to spend time doing relatively mundane tasks while they are kind of building this environment and being able to, position themselves to extract value out of the data. Now, in big data, in this kind of new environment, much like in traditional data, much of this work is done through workflows and batch processing. And one way that we have seen and we've been able to help customers sort of accelerate this entire process and really begin to move towards getting value out of their data is by automating this significantly. And so all of this process of being able to move data around, make sure that it's prepared, much of the, the steps that Michael referred to in making sure that you have the right data, that you have all of the data available, that the data is there at the time that you need it, and that you don't start certain processes until the data that you expect to be there has actually arrived and arrived successfully. And all of that manipulation and orchestration is what we help customers be able to deliver. Now, frequently customers will think, well, we're focusing on figuring out how to extract insights and value out of our data. We will think about operationalizing it a little bit later. And that's kind of a really critical, a critical point that we feel you really have to think about very deeply, because as I mentioned, the process of being able to position yourself to collect the data and to be able to start actually extracting value out of it, if you can accelerate that process, then you can get to the end goal much, much more quickly. And so we've been working with many customers that and using our technology to enable them to do exactly that. Very early in the process, instead of having to do a lot of scripting and to do a lot of this kind of integration with the existing environment, instead, they can use our solution to be able to make that entire process much, much quicker, more efficient, and to save much of the trouble and the aggravation of having to build all of this integration manually and to be able to run it. So we provide a solution that really allows them to abstract that entire notion of how you manage workflows. And it really doesn't matter whether you're dealing with big data exclusively or a combination of big data and traditional environments. Because, again, what we have heard from almost every customer that we have worked with, that any organization of any size that has been around for any amount of time has a great deal of traditional data that they want to be able to revive or to be able to access and to sort of merge with some of the new data sources that they have so that they can enrich really the combination of their existing data as well as this new data on which to build their analytics and to gain the insights that they're looking for. And so our solutions are focused on enabling them to do that. And by applying and starting to use these technologies that we provide very early phase, they can actually build out their applications. They can have more successful POCs much more readily than if they had to build them by hand. So what we find is that this process of building what we call workflows is fundamental to actually developing big data applications. That if you think a couple of slides back on the little boxes that popped up, that is creating the process or managing the process of transferring data, of being able to run and rerun your sort of algorithmic tests, because one of the things that also happens is that there's a lot of repetitive work that has to be orchestrated. So you may find that you develop an algorithm, you test it against some data, it may produce some results that you then want to refine, and you iterate, and you iterate, and you do that over and over and over again. And so the process of building and managing these flows is something that begins very, very early in the process of building and delivering big data applications. And rather than just thinking about how this is going to run eventually, once you sort of turn it over to somebody else to operationalize, we find that the customers that we've worked with that have had the greatest success are the ones that have started using this kind of technology very early in the process of being able to manage and leverage this during the build, so that just like in traditional computing environments, where you can really think about computing being done in kind of two very general major categories. There's this real-time interactive processing, and then there's batch that's managed by workflows. The same is true in the big data environment. We find that even though when you think about big data, many times you think about data that is streaming and in motion, but the reality is that much of the processing of making sure that you have the right data, that you merge it with some of the data that you already have stored, managing the flows and the integration that are involved, all of these things are done in some kind of batch mode. And using the right tools and technology to build those batch flows, to be able to not only construct them initially, but also to do your initial testing and to do your system and integration testing, you can achieve far greater and sort of faster time to market, if you will, than if you leave that or defer that action till later. Now, in addition, of course, there is a lot of value in how you actually do operationalize your big data application. So not only do you have to kind of develop them and build those algorithms, but you then do have to eventually run them and run them repetitively. And part of the operational aspects of running these things repetitively is also making sure that all of the data that is required to drive these processes arrive and are available right on time, and that they're correct as well. And so not only can you build your applications faster if you start using workflow technology much earlier in the process, but also once you actually do start operationalizing them and getting to a point where they do deliver value to the organization, you gain a tremendous amount of capabilities in terms of notification and alarming and alerting and managing service levels, providing easier access to less technical or non-technical users so that they can either access or watch or interoperate, if you will, with the workflows that are important to them. You can give them via self-service mechanisms and tools like mobility support the ability to run queries and analytics on an ad hoc basis. So, in summary, what we have been learning from working with all of our customers is that batch and the way to schedule that batch and to manage the workflow is kind of a fundamental technology that's part of helping them build applications faster, get them into running or operational modes and deliver value to the organizations much more quickly using this kind of technology.
Well, thanks very much, Joe. Really appreciate that. And I'd like to now turn the program over to our last guest, Rajiv Mather, and have him talk about more specifically some of the practical uses they've had at the IRS using big data analytics. So, Rajiv, I'm going to turn it over to you. And please, again, we've got a couple questions come in, and I will address those at the conclusion of Rajiv's presentation. But use your Q&A panel if you have some additional thoughts or questions you'd like to ask. Rajiv, I'll turn it over to you.
Well, thanks, Wyatt. Good afternoon, everybody. And you've heard from some great speakers today, and I guess I'll be the cleanup hitter on this. So what you're going to hear about today is some of our experiences here at the IRS when it comes to data or big smart data. And before I get into it, I guess one thing I'd like to start with is that in some way we were doing big data before big data was cool, right? Certainly when it comes to data, we get a lot of it, and we end up using it to meet the mission of administering the nation's tax system, and the mission, of course, being to provide America's taxpayers with top quality service by helping them understand and meet their tax obligations, right, and enforce the law with integrity and fairness to all. And so in meeting that mission, you can't help but work with data and information in order to execute on that. And we're on a journey. And what you're going to hear from me today is about some examples, but really about the journey towards the future of a better digital customer experience using the concept of big and smart data. I say that it's a journey because there's much that has to be done to really make it work, and it's not about technology. You heard about that. You heard that today. A lot of it is about business process and is about empowering the right people in the organization to be able to use the information, right? And our lens that you're going to hear about today is about the customer experience. So within the agency, the main focus that we're using data for is to use data to drive a better customer experience in the digital channel. So with that, let me jump to the first slide here. It's not about big data, it's about smart data. And so the top of the slide here, of course, the data lifecycle, pretty generic, right? You look at it, you source the data, you ingest it, aggregate it, store it, analyze it, disseminate it in some way. It's simple. It's been around for decades. So what's the difference between what we have here and what you're hearing about today and the buzzword of big data? The use case that I'd use again in the lens of customer experience in the digital world is what's different is that in the life cycle, the difference is in the sources, the types of information that you're going to get, and you heard about that from Dr. V earlier. The volume or the amount of data, the flow of information, and I kind of put all those into two different ways or ways to look at information or data. One is what I would call the force of data, and the other would be the velocity of data. If you are physics students in the audience there's force and velocity. The force of data, what I mean is the amount of information, and in this case, per unit experience, right? That's the unit of measure for us. So if you're measuring customer experience, which we'll talk about today, how much experiential data do we have, and how do we use that data to drive to a better experience? How many different types of information, how many different sources to be able to describe that experience. If you're coming into a call center, if you're coming into the digital channel, before you actually get to the thing that you need to do, what do you have to get to or go through to do the business that you have to do with the IRS? That all counts towards experience, and all that data should be captured and help us make decisions. The other piece is the velocity, or how fast that data is moving. And again, in physics terms, the data coming in per unit experience over time, and time is the key element here. So force and velocity are certainly the different pieces of where we are today when it comes to data in this old new world of data, right? So with that, let me move to the next slide. Here. And what does big data mean for the government? And what you see here are three different flavors. One is the traditional data sourced or coming from the Internet of Things. You've heard this definition before, of course. Another way to look at it might be starting with the customer and what I call the back end and operations analytics. So large data sets that may exist across service and compliance, across channels, and perhaps across agencies, and how do we learn more about those customers. And in that case, it's really about who the data is about, what they're doing, what they're trying to do, whether the data is public or whether it's coming through private sources, and using consumer analytics in these large data sets across multiple, both internal and third-party channels to paint a picture of who the user might be, and how do we then deliver a better overall service and compliance experience to them. Right. Then if you move to the third flavor, that's the experience analytics. That's largely what today's conversation is about, and that's to improve the experience for digital. So we look at interaction data sets throughout that experience lifecycle. You'll see some of it today, and using the taxpayer lifecycle of pre-file, post-file, and filing itself. Right. So how do we continuously learn and improve that experience? And we do it. We've been doing it for a while on IRS.gov. The question is, how do we do it now in more real time, and how do we do it in a way that can help drive the experience better as we're going forward on it? So let me move to the next slide here. The quote you see here is from our esteemed deputy CTO and chief data scientist, right? And the user doesn't want to see raw data. I'll let you read the quote itself. But how do we make the data actually usable by all our audiences, whether they're internal audiences, customer service reps, or product managers, content editorial managers, analytics folks, or user experience and design folks in the digital channel again, or how do we, or even customers in this case. Moving on to the next slide, as I mentioned, we use data throughout the decision-making process. And as we look at how will this data be used to help our operations in the future, we are looking across. We really are looking cross-channel analytics to look at the channel mix, for example. So what new measures do we have? It's not about necessarily level of service on the phones, but it also might be about what that experience is going to be in the digital channel and completion rates, for example, for filling out an installment agreement. What percentage of of installment agreements are coming in through one channel versus another. Or what percentage of refund inquiries are coming through one channel versus another. Again, these are new measures that measure the efficacy of that experience, and they'll help both internal operations and external operations. The other piece I wanted to point out here is that when we were looking at the experience, a couple of examples that I'd share with you in the spirit of showing and not telling is we have, for example, a version of a heat map for a page. When you look at a page, what are people clicking on in real time? And you can see that in the past we've done is we've looked at a heat map for a page and seen that in certain cases the clicks are actually happening way at the bottom of the page, continuously, day after day. Well, why not move those links at the top of the page? Clearly users are searching and reading through pages, and they're going to the bottom of the page. So let's just make it easier for them by moving those links to the right place and making sure the messaging is in the right place. Another example is what we're calling the customer early warning system, the queues system. So it's really more of a process and not a technology system, but using social media, using our call center information, using what's happening on the web to help call center reps perhaps be able to respond to folks that are calling in a more applicable way, in a more real-time way based on what's happening on the web or in the call center. So again, this requires real-time information. It changes the velocity of information, but it does help us systematically change the experience as we go through this. So moving on to the next slide, how do we go forward, and how do we go forward in this journey when it comes to the government in getting to bigger and smarter data? And what you see in front of you are it's really not about technology. It's about driving a better culture, right? So one example of this that we did probably a year and a half ago or so is something called Service on Demand, and in that we look across all the different channels and looked at how are we touching taxpayers today. So 736 million touches a year. They're coming in to do refund inquiries. They're coming in to file. They get notices that we send out. They make payments at filing time and for installment agreements and other touches. So either they may initiate them or we may initiate them. And so looking at this data, again, this is longitudinal information, and then trying to figure out how do we use this information to better segment the audience, and then driving better experiences for them. So within online services at the IRS, when we're looking at the domain knowledge, we're looking at what is that customer experience look like for the typical IRS client. What should our product folks, our content folks are looking at those pages. They're looking at the payment stream, for example, and not just the digital stream, but the digital and the non-digital stream. So, for example, there's some folks in this audience here that were responsible for IRS direct pay, and that allows a taxpayer to pay online using a routing number and an account number. Now that was the result of a lot of analysis around how are people looking to pay us today, and how do they pay us? They write us physical checks, they go to lockboxes, and eventually they get posted to the account. Well, in other parts of their life, they're making payments through ACH debit. So how do we allow that to happen? Refund inquiries is another example of using data. We know that, for example, early filers are particularly sensitive to refund cycle time. And so maybe their messaging should be different. Now, we're not there yet today on where's my refund. But at some point in the future, should we think about using the time of filing, the early filers, for example, being able to give them more specific messaging or more frequent messaging when it comes to their refund status. They may be calling us for tax law information. Again, we need the domain knowledge of both the web and the tax law to be able to drive to a better outcome. And getting to a better taxpayer burden, or the reduced taxpayer burden. At the end, it really is all about creating value for the taxpayer, and using analytics in the data stream, in the click stream, and then applying some of those insights to either rearrange the digital experience, reorient the message, make the message simpler. All that was about service on demand. Looking at these different touches, the categories of touches, the types of customers that are coming to us, whether they're businesses or individuals, and then delivering a better experience. So we're well on our way to that digital future, but really grounded in data. So let me walk you through an example of the experience based on what good data may result in. So when you're looking at measuring the customer experience, this journey map that you see in front of you here, let me just walk you through it in a little bit. So Kylie is a single mom. Works at a bank. I don't know if you can see the slide. It's actually cut off my screen here. Needs help managing her taxes and combating ID theft. She's a full-time bank manager and a homeowner. So while she's browsing her favorite site, she sees a targeted message that recommends she should sign up for an account with the IRS and to see her refund status and change her communication preferences. She then files a return as soon as possible, as soon as filing season starts. So she's one of those early filers, and she may have a particular sensitivity to making sure she knows when her refund check is going to come in. She uses a mobile app to check her refund status right away, but there hasn't been an update. So she's wondering why there hasn't been an update. She opts into mobile SMS, and that alerts her at any time that her refund status changes. And a couple of weeks later, she may get a notification that says she's been a victim of ID theft and she must confirm her identity. So then she goes back to her online account. She signs in electronically and then signs an affidavit and submits the required documentation by snapping a picture on her phone. She then calls in, and as she's calling in, the IRS agent says, "Hi, Kylie, are you calling about your identity theft situation?" And the agent then confirms that we received the right documents, that the CSR actually sees and asks a series of questions to authenticate Kylie, and then releases the refund because the refund's been held. Kylie then can check her online account and then subsequently check her bank account and sees that there's a updated date for her refund and that there's a record of her filing and that even her call to the IRS. Again, this is a future state example of how data could be used to really drive this experience. At every step of the way, we're going to need information to be able to get this experience to where we need to get it, and that's probably one of the biggest pieces that I'd like to leave you with is getting the information is one piece of it. Storing the information, being able to do it with high velocity, high enough velocity, fast enough is certainly one big piece of this. But making sure that you can do this with the right skills in place is a huge part of it. Getting the right data to the right person or persons is a really important part of delivering better taxpayer service, especially in light of potential declines in service that we're seeing due to the increased demand that we have and then the budget constraints that we have. So as I mentioned, when we're touching taxpayers 740 million times a year, we need to make sure that we're touching them efficiently. So in some cases, when they don't need to be able to interact with a person, they should be able to go right through. And this journey map that you see here should be self-service completely. Could be self-service completely. And in other cases where they need to touch us, they should be able to touch us. So when you need to be able to get to us and be able to interact with us, you do that. So how do you then make sure that the right taxpayer touches go to the right channel? Really based on taxpayer choice, but by introducing the right transactions, the digital interactions within this service-on-demand service strategy. Can we, for example, deflect sending you a notice? Instead of sending you a notice, sending you an electronic notice. Can we give you a text message of when your refund will be delivered instead of having you to call in and find out when it is? A lot of our calls, for example, are to ask about what exactly the payment amount might be, and because they're going to mail a check next Tuesday. Is there a way for us to then deliver an experience where you can check the status of your payment amount without having to call in and figure it out? So I talked about the measuring the customer experience here. So while we were able to identify the opportunities for better service during service on demand and using the service on demand approach, we realized that we could manage our data more effectively by also being able to make this a recurring process, right? So one of the things that we want to be able to do is to provide clear tools to be able to visualize this data and visualize it and visualize the customer transactions and interactions. So as an example, we get installment agreements through various different channels. We get them through obviously our taxpayer advocate. We get them through call centers. We get them through mail, and then of course we can get them online. So how do we promote that mix, both online and offline, preferably online, to be able to visualize that and see the channel mix at any given time? The other piece of being able to, once you're able to measure what that experience is going to be and what the channel mix is, it drives the right behavior because you now have transparency across the channel. You actually have real data that's driving some of your decisions. So hopefully you get rid of some of the biases and you can promote a more even-handed information exchange. And then finally, getting operational transparency is important to be able to let taxpayers know where, for example, their refund or the return might be in the process. We would no longer be a black box necessarily, but you can see exactly where you are in the tax assembly line, if you will, or the tax return assembly line. We're using technologies and methodologies like Agile to be able to deliver on some of this stuff. Again, this is all early. We're on a journey. How do we deliver better experiences online? And then, of course, we're going to need to look at how we measure this, the metrics, the cross-channel data, and then reevaluate how do we measure success. I'll leave you with a quote from Todd Park that we want to open up data to make our government awesome. And in our case, it's not open up data to anybody and everybody. It's open up data for the taxpayer because it's their information and they need to get it in a secure way and they need to be able to use it in a secure way, the way they need to be able to get to it. So how do we do that in a way that's transparent and easy and let them do what they need to do to meet their tax obligations? And with that, I'll hand it back to you, Wyatt.
Rajiv, thanks so much. We've coming up on the end of our hour. I'd like to squeeze in a couple of very quick questions, if I may, before we wrap up. I have one here. I think a common one is regarding privacy. And just briefly, Rajiv, maybe you could take this one first. Is how do you preserve privacy functions while collecting this? Do you have individuals that monitor that? Do you have big data tools that do that? Just briefly, how do you address privacy?
We do have very strong privacy safeguards in place, and of course, as some of you may know, we're governed by 6103 and other regulations around how we can disclose information. So there is quite a bit of safeguards in place that we all have to follow, all employees have to follow. We have processes in place, and our privacy and government liaison group is responsible for much of that.
Great. And Robert asked, in a different vein, you had mentioned kind of monitoring the customer experience, and he wanted to know, is there a way to measure the mood of a customer's experience, and do you factor that into the responses?
Well, like I said, we're on a journey, so some of the things that I talked about, we certainly aren't there yet. It's tough. That one could argue that's the holy grail of measuring the mood, the sentiment. I think looking at one interaction is going to be tough. It's tough to figure out the sentiment, but once you can look across different touches, for example, if they're coming into a call center and then they're also checking online and they're going back to a call center or they're walking into our service center, sure, that may imply some frustration, that may imply anxiety, that may imply that they have a dire need, right, clearly. So that may be one way to think about it. We're not there yet, but that's certainly one way to think about it. It's tough to do.
Well, I appreciate addressing it as a journey, as it certainly is, and I'm afraid our journey here is coming to a close. We need to wrap up here. I know we had a couple of other questions, and what we'll try to do is respond to those of you by email to get you some of those answers. But with that, I'd like to thank our guests today, Dr. Michael Valavula from NASS, Joe Goldberg from BMC, and Rajiv Mather from the IRS for taking time to walk through some of the things that you're learning. I also want to thank our audience for tuning in today, and also just as a reminder that lets you know the program is available on demand. It'll be available starting tomorrow and up for the next 90 days, and you can access it using the link that you had sent to you by email. So send that along to your colleagues who might benefit from this. And also a final reminder that you can download the whole slide presentation with the resource listing on your console. Look for more of our coverage on data analytics and big data on FedScoop. And on behalf of all of us here at FedScoop, this is your host, Wyatt Cash. I want to thank you for being with us today.